Hey, today we are going to talk about algebraic expressions. There will be some new vocab terms here. Some of them you may have heard of already. The first one is a variable, and a variable is a symbol that represents an unknown quantity. Um, Whenever you see a variable, it's going to be a letter. So please write that down so you remember. A variable is when there is a letter in the problem. It is also what changes in the problem. So, for example, if you look at what we did last week in our last section of the notes, there was a problem where Sarah would babysit and get $8 per hour, and she got $5 per week for allowance, and we made a table for her babysitting for 6, 7, 8, and 9 hours. Since the number of hours changed, we could make a variable for that rather than having to make a table for all of them or an expression for every single one. So our problem last week was $5 for the allowance plus $8 per hour, so 8 times the number of hours. Since the number of hours is what changed, and it could be anything, you could babysit for 10, 8, 6, 12, it doesn't matter. It's going to be our variable. So let's use H for hours. So this is how we would use the variable in the previous example. This is an example of an algebraic expression. Because it contains a variable, a number, and at least one operation. Remember that when I say operation, I'm talking about multiplication, division, addition, and subtraction. Just those four basic things we do in math. So an algebraic expression will be any time we have those things, a variable, a number, and an operation. So let's think of some other examples of an algebraic expression. We could do something as simple as x plus 3, so some number plus 3. You could do a over 4, which is a divided by 4. You could do, let's say, 3 times x. Whenever you have the number and the variable right by each other like this, it just means multiplication, which we're about to talk about. And you can also do, let's say, 9 minus n. So anytime you have the variable, the number, and something that's going on, it can even be more complicated. Like, for example, this one, the 5 plus 8 times h, that has two operations. It has addition and it has multiplication. So down here it says, in math, the multiplication sign is often omitted. So here, we don't see anything that's actually a multiplication sign, but they all mean multiplication. So this means 5 times n. The reason that mathematicians don't write the little x as your multiplication is because it can look like a variable. That's why we get rid of it. This means 7 times m times n. So you could write it all in parentheses if you wanted to separate it a little bit. And this means x times y. So here, there's actually 4 different ways that you could write a multiplication problem. You can get rid of everything, you can put a little tiny x, you could use parentheses, or you could use a dot. In this class, throughout the year, you will see me just have nothing, so the number right by the variable, and you will see parentheses. I will almost never use a x for multiplication or a dot, because that looks like the x looks like a variable and the dot looks like a decimal, so I don't use them. The next vocab term is the number in front of the variable is called a coefficient. So coefficient is a pretty strange sounding word, but it's super easy. You won't have to actually solve problems saying something like evaluate the coefficient. That doesn't quite make sense. So when we talk about coefficients, they're just going to want you to identify it. So this first question, what is the coefficient of 5n? Well, we just said it's the number in front of the variable. Here's my variable. The number in front of it is a 5, so the coefficient is going to be 5. So the next question was the coefficient of 7mn, which is 7. It's just a number, that's it. And you don't have to do anything else. The next example say to evaluate, so we are going to solve the algebraic expressions. So here, number 1, evaluate t minus 4 if t equals 6. So if t is 6, then I can get rid of this t and replace it with the 6. So I have 6 minus 4, and we get 2. So all you do is take out the variable and put the number in place of it. Number 2, evaluate 5x plus 3y if x is 7 and y is 9. Okay, so x they said was 7, so I'm going to take out my x and put a 7. Notice this time I put parentheses around it so that it doesn't look like 57. I don't have an x, I don't have a dot. Parentheses work as multiplication. So 5 times 7 plus, then I have 3 times y. Y is 9, so take out the y, put a 9. And then it just becomes a problem with order of operations. So we'll do our multiplication first. 5 times 7 is 35. 3 times 9 is 27. I'm going to add those together and get 62. Number 3, I'm going to evaluate 5 plus a squared if a is 5. So I've got 5 plus a they said was 5, so I'm taking out my a and putting 5 there, and then squared. Order of operations says to do your exponents first, so you have 5 plus 5 squared means 5 times 5, not 5 times 2. 5 times 5 is 25, so 5 plus 25 is going to give me 30. Now I'm going to write another example off to this side, so this is example 4. And it's 3x over 2y, x equals negative 4, and y equals 6. So 3x means 3 times x, so I'm going to take out my x and replace it with a negative 4, and put it over 2 times y with 6, so take out the y and put a 6. Now, we have not yet covered multiplying positive and negative numbers, but you should remember it from last year. We will do some review with that next unit. But 3 times negative 4 is negative 12. If the signs are different, it's negative. Over 2 times 6 is 12. And then we have negative 12 over 12, which means negative 12 divided by 12, which is going to be negative 1. I want you to turn over to the back or the next page. And here's an additional problem. It says Leah has already read 20 pages of a book. She plans to read 5 pages each day from now on. Write an expression that represents the total number of pages she will have read in D days. Okay, so she's already read 20, so we're going to start with 20. And since it's the total, we know we need to add something to it. And 5 pages each day. Well, the number of days can change. They told me to use the variable d for days. So 5 pages each day would be 5 times d. So there's my expression. The next part says, will Leah have read more than 60 pages in 7 days? So since they say 7 days, that means my d for days is going to be equal to 7. So I'm going to take out my d and replace it with a 7. Make sure you take out the parentheses, make sure you keep the parentheses and don't just write 5 and 7, because then it's 57. Do multiplication first. 5 times 7 is 35, and 20 plus 35 is 55. So she's going to read 55 pages. So no, she did not read more than 60 pages. So make sure that you actually answer the question that they ask. Don't just stop at 55. Our last problem says the formula for rewriting a Fahrenheit temperature as a Celsius temperature is 5 times F minus 32 divided by 9, where F equals the temperature in degrees Fahrenheit. Find the Celsius equivalent of 77 degrees Fahrenheit. So this 77 degrees Fahrenheit tells me what my F is going to be. F equals 77. And that's all I needed to solve this problem. So we have 5 times, replace F with 77, minus 32, divided by 9. Oops. My order of operations says parentheses first. So 77 minus 32 is going to give me 45. And divide by 9. And 5 times 45 is going to give me 225 over 9. And 225 divided by 9 is 25. My label is going to be degrees Celsius since they wanted to know what the temperature is in Celsius. So that's our start with variables. So just take out whatever variable that they have and replace it with the number and solve using your order of operations, and you'll be good to go.